Hi everybody. So today we're going to be going over the Delta Math homework number 14 on short proofs and triangle congruence and proving triangles congruent. So in this video, I'm going to go over the 4 short proofs questions and also the last 3 triangle congruence questions as well. So let's get started and take a look at the first short proof together. So everybody sees the same proofs in this Delta Math assignment. I selected the same ones for everybody, so you all should be seeing this proof over here on your own screen. So before we get started with figuring out how to type this into Delta Math, let's discuss it together. So give me 1 second. There we go. Let me pull up my other screen over here. So they tell us in the givens, let me make sure this is the same one. Yes, it is. So they tell us in the givens that BC is parallel to AD. So let me get my highlighter and I just want to highlight these 2 parallel segments. So that's BC, which is right over here, and AD, which is right over here. I'm a terrible highlighter. And they also tell us that AB is parallel to CD. And our ultimate goal is to prove that angle BCD, so this angle over here, is congruent to angle BAD, this angle over here. Before we take a look at the second pair of parallel lines, AB and CD, let's just stick with this first pair for now. I also want to highlight the transversal that connects the 2 parallel lines together. And notice the letter that's made when I highlight the parallel lines and the transversal. It is the letter Z. Now, if you think back to class and you remember the type of angles that are formed in the corners of the Z's, you'll remember that we have alternate interior angles. And we know that alternate interior angles are congruent when lines are parallel. So already we know that we have a pair of alternate interior angles that are congruent to each other. Now let's go to the second pair of parallel lines, which is AB and CD. Let me highlight AB in a different color and also CD. And AC is also the transversal that connects these 2 parallel lines. Notice how AC intersects AB and CD. So notice it's backwards, but it's also the letter Z when I highlight the parallel lines and the transversal in purple. So whenever we have the letter Z in the corners of the letter Z are the alternate interior angles. And remember, once again, alternate interior angles are congruent when lines are parallel to each other. So if I was writing out this triangle congruence proof, I just want to show you how I would be doing this so far at this point. And then afterwards, we'll talk about how to put it into Delta Math because Delta Math is a bit weird with how you have to type things in. Everything kind of needs to be the way that Delta Math wants it to be. So first we'll write it up the regular way by hand, and then we'll put it into Delta Math. So once again, my first given, I should write it, I'm not going to write it in yellow because yellow is kind of hard to see. BC is parallel to AD. That's given. From that given information, we were able to draw the conclusion about the red angles being congruent to each other. That was angle DAC, angle DAC, and that was congruent to the other red angle, BCA. Okay, and our reason for that is that alternate interior angles are congruent when lines are parallel. Okay, then we also have our next given, which is the other set of parallel lines, AB and CD. And that's given to us. And from that given, we were able to draw the conclusions about the blue angles. The blue angles are angle BAC, and that's congruent to angle DCA. And the reason, once again, is that alternate interior angles are congruent when lines are parallel. So I'm going to write here same as step 2. as step 2. So remember, our ultimate goal is to show that angle BCD, which is BCD, this whole angle over here, is congruent to angle BAD, which is this whole angle over here. So since we have information about the red parts of each of these angles and the blue parts of each of these angles, and we need to get information about the whole angles, we're going to be using the addition postulate here to combine the information about the parts of the angles in order to get the whole angles. So let's do that in the next step. So in the next step, I am going to write angle DAC, which is one of our red angles on this angle, plus angle BAC, which is the blue angle right next to it, is congruent to angle BCA, which is this red piece of the angle over here, plus angle DCA, which is this piece of the blue angle right over here. And that is by the addition postulate. Let me write that down here. Addition postulate. Now, let's just verify that our addition here works. So remember, in order to use the addition postulate, you have to be starting with two congruent angles. So we did make the statement in step number 2 that angles DAC and BCA were congruent to each other, so that's all good. And we also need to be adding congruent angles. And in step 4, we definitely made the statement that angle BAC and angle DCA are congruent to each other. So that's all good, and that works. Angle DAC plus angle BAC, so this red angle plus this blue angle, give us this whole angle, which is angle BAD. And that's congruent to angle BCA plus angle DCA. So here's angle BCA. When you add it together with angle DCA, the red plus the blue give you the whole angle over here, which is angle BCD. And that's by substitution. All we did was replace the addition with what it actually was. This plus this was this. This plus this was this. After addition or subtraction postulate, always comes substitution. So we've written out the entire proof here. We've proven what we're trying to prove, that angles BAD and angle BCD are congruent to each other. So now we just have to attempt to rewrite this into delta math, and that should be fun because delta math is really annoying. So why is it not letting me do this? Okay, here we go. So the first thing we talked about was the alternate interior angles. So which ones did we do first? We did the red ones first. That was this one and that one. Okay, so that's angle BCA. BCA is congruent. So BCA is here, so it's congruent to this one. That's angle DAC. And our reason is about alternate interior angles. Parallel lines cut by a transversal form congruent alternate interior angles. That sounds correct. Let's try it. All good. Now we have to mention the other pair of alternate interior angles. So that's angle BAC. That's one of them. And angle DCA is the other one. And that's once again the alternate interior angles that we talked about before. Okay, and then we combine the information about the two parts of the angle to get the whole. So we use the addition postulate. Delta math is a bit weird here. We showed out the addition, which is what you should do on a test or the Regents exam. You should actually show out what you're adding with the addition postulate. But delta math is really strange. And delta math doesn't want you to type everything out. Delta math just wants you to say that you, from this information, drew the conclusion that angles BCD and BAD were congruent to each other. And they want you to say that it was through the addition postulate, but they don't actually want you to show out your addition. So, okay, here we go. And they don't write addition postulate either to make it more confusing. When I started typing addition, I get this reason here. Congruent angles added to congruent angles form congruent angles. So that's a really long way of writing the addition postulate. Okay, and now if I submit this, it should work. Okay, awesome. Let's move on to our next one. So the next one on Delta Math is this one right over here. Once again, everybody should have the same exact thing. This one looks really similar to the previous one, but it's a little bit different. Oh no, why do I have one in between? So it looks like I skipped one. So let's do this one first. So this one says, given AB is perpendicular to BC, we need to prove that angle A and angle C are complementary. So if I was going to write this out from knowing that AB is perpendicular to BC, I would be able to draw the conclusion that they form a right angle. And that's already here in the diagram for us. From knowing that we have a right angle in this triangle, I know that we have a right triangle, which is a 90-degree angle. And since this is a 90-degree angle, and all the angles in a triangle add up to 180, I know that whatever this angle is, plus whatever this angle is, must add up to 90 degrees to make the 180 with this one. That means that these two angles need to be less than 90 degrees. They need to be acute angles, right? Because this plus this should add up to 90, because adding it to this 90, we get 180. So I'm not going to write this up. We're going to just try to put this into Delta Math and hope we can do this accurately. So we were given that AB is perpendicular to BC. So I'm going to mention the right angle next. So they have a specific one here to mention something's a right angle. So angle CBA, or we could just write angle B, is a right angle. And the reason is that perpendicular lines form right angles. We were told that the line segments were perpendicular. Okay, and then we figured out that since this triangle has a right angle, it's a right triangle. So let me classify a triangle as a right triangle. Yes. So I want to say triangle ABC is a right triangle. And the reason is that the triangle contains a right angle. Okay, now from here, I can draw the conclusion that angle A and angle C are complementary. They need to add up to 90 degrees. Because since all the angles of a triangle add up to 180 and this one's already 90, this plus this has to be 90 as well. So I'm going to now draw the conclusion that angle A and angle C, oh no, I didn't want to say they're congruent. I want to say they're complementary. Angle A and angle C are complementary. And let's see the reason. So we said it out loud, but let's try to find it here. So this one over here seems to be the one that looks like what we're looking for. The two acute angles of a right triangle are complementary. Since these two angles need to add up to 90 degrees, they each must be less than 90, and they're complementary because they have to add up to 90 because 90 plus 90 makes 180. So let's check it out. And there we go. We did it. Let's move on to the third one. So that's this one over here. So this one looks really similar to the first one, but it's actually a bit different. So let's write on it and talk about what we're going to do here. So we're given once again that BC is parallel to AD. So just like we did last time in example number 1, I'm just going to highlight, I'm going to just highlight those two parallel lines and the transversal that connects them. So here's BC and here's AD. And here's the transversal that connects them. And just like example number 1, we have a Z letter here. So the angles that are inside the corners of the Z are alternate interior angles, and we know that they're congruent because the lines are parallel. We also have a second set of parallel lines. So that's AB and CD. So I'm going to highlight those next. So here's, oh no, this computer is terrible. Okay, so here's AB, here's CD, and here is the transversal that connects both of them. So that's a backwards Z, but it's still a Z letter, it's just backwards. So inside the corners of the Z, we have another pair of alternate interior angles. Sorry, it won't let me click. There we go. So let me just mark my other pair of alternate interior angles. We know that they're congruent because the lines are parallel. Now remember we learned in class, whenever we have two triangles, and in the two triangles we have two pairs of congruent angles, we said that the third pair of angles also has to be congruent to each other. And remember we saw it with some numbers. We said, well, if these two angles here are 60 degrees, where is my pen? So if these two angles here are 60 degrees and these two angles here are 30 degrees, well, this is 60 plus 30, that's 90. So the other angle of this triangle must be 90 to add up to 180. And in this triangle, if this is 60 and this is 30, well, that's 90. So this angle also has to be 90 to add up to 180. So no matter what numbers we had chosen here, as long as two angles in the triangles are congruent to each other, the third angle also has to be congruent to each other. It really doesn't have a choice because all the angles in any triangle have to add up to 180 degrees. Let me get rid of the numbers because that was just an illustration. There are no numbers in this question. So I'm going to mark here that the third angles in the triangles are congruent to each other. And that's what we were trying to prove, that angle B is congruent to angle B. So let's try to put this into delta math and see if we can do that. Okay, that was the question I was on. Okay, so first we talked about the alternate interior angles. We did the green ones first, I believe. The green ones are here and here. Okay, so that's angle BCA and angle DAC. And that was because they were alternate interior angles. Okay, now we have the other pair of parallel lines and the alternate interior angles that they create. So that's angle BAC and angle DCA. And that's again because they're alternate interior angles. And then we talked about, since we know that two angles in the triangles are congruent to each other, the third angles also have to be congruent to each other. So that's angle B being congruent to angle D, which is our goal as well. And I'm just going to look for the reason that says what we said out loud. Oh, here it is. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. Perfect. That's exactly what we just talked about. And there we go. We got it correct. Yay. Okay, our last short proof. So let's talk about this one together. Let me pull up my page over here. So it says that CD is an altitude of triangle ABC. So this is an altitude of the triangle. Remember, altitudes are perpendicular lines. That means that they form right angles. That's all we know about altitudes, that they form right angles. Our goal is to show that triangle ACD is a right triangle. That's this triangle over here. But wait, we showed that already, right? We just found out that there was a right angle in this triangle, and that makes it a right triangle. So that was simple. We just have to put it into delta math. Let's do it. So I'm just going to put exactly what we said before. So we said that there were right angles here and here. So I'm going to put the one that's in triangle ACD because that's the triangle that we're really interested in showing is a right triangle. So that's angle ADC right over here. So I'm going to put a right angle. So angle ADC is a right angle. And the reason is that not perpendicular lines. We have an altitude. Can we not put that in here? Let's try this one. Oh no, delta math doesn't like that. That's why I don't like delta math. I want to say something about the altitude. So let's figure out what we're going to do. So delta math doesn't like this. So maybe I want to say that CD is perpendicular to AB. And maybe we can put the reason that altitudes are a perpendicular line. So yeah, here, look, an altitude of a triangle is perpendicular to the side to which it is drawn. Altitudes are perpendicular lines. We actually have to put that step in. Yeah, these two lines are perpendicular because we have an altitude. So now we can make the statement that angle CDA is a right angle. Let me find the right angle one again. Angle CDA is a right angle. And now we can put perpendicular lines form right angles because we said that CD is perpendicular to AB. Okay. And from here, now we know for sure that triangle ACD is a right triangle. And we know that because the triangle contains a right angle. So this should all work now. We are all good to go. We did it. So that was the last short proof. So I want to go over the triangle congruence flowchart proofs now. So it's going to be the last 3 questions on delta math. So let's take a look at this first one first. So they tell us that E is the midpoint of BD. And I don't think we know anything else. So let me take a look over here so we can put in the information together. So if we know that E is the midpoint of BD, where's BD? Right over here. We know that it's splitting BD into 2 congruent parts. And from our givens, we already know that CE and AE are congruent to each other. I can also see that we have vertical angles here. So I know vertical angles are always congruent. So I'm going to present. Now I see that the 2 triangles are congruent by side, angle, side, side, angle, side. That's SAS. So let's take all the information that we have here and let's put it into delta math. So remember, our proofs always start with our givens. So I'm going to just put in the given that they give us. CE is congruent to AE. That's already in the diagram. And I'm going to put given. This is a weird flowchart. Okay, so maybe here, because they want us to draw a conclusion from this given, maybe here we should put the fact that E is the midpoint of BD. This is why I don't like delta math. So E is the midpoint of BD. Delta math always wants things a certain way. That's given. Now, from this given, we drew a conclusion, so that makes sense with the arrow pointing down. So we drew the conclusion, what did we draw? That DE and BE were congruent to each other from having a midpoint. So let me put that in. DE and BE are congruent. And our reason, let me type in about a midpoint. A midpoint divides a segment into 2 congruent segments. Awesome. Okay, so I have to mention the other given that CE and AE are congruent to each other. That's given. And the last thing I have to mention that we talked about is the vertical angles. So let me name the vertical angles and say that they're congruent to each other because vertical angles are always congruent. So that's angle CED. That's this one here, and here angle AEB. And our reason is going to be something about vertical angles. Vertical angles are congruent. Awesome. And that shows the triangles are congruent by SAS. We did it. Okay, let's take a look at the next one. I really don't like delta math. So the next one says that AB is parallel to DC, and that's all we got. So let's think about what we're going to do here. Oh, we also have that AB and DC are congruent to each other. I see that drawn in here. Let me mark that AB and DC are also parallel so we can see that. So they're congruent and parallel according to our given information. Since I know that they're parallel, I can highlight them. And I can also highlight either one of the transversals. I'm a terrible highlighter. So I can also highlight either one of the transversals that connects them. So I'm just going to highlight this transversal, but you can definitely highlight the other one instead if that's the one that you want to highlight. The other one would be over here. It connects both of the lines as well. So I have a Z shape, a Z letter, I should say. And inside the corners of the Z's are our congruent alternate interior angles. Now, if you took a look at Delta Math, they tell you that they want you to prove the triangle's congruent by AAS. So we have an angle and a side, and we're going to need another angle. I see vertical angles here, and I know that vertical angles are always congruent. Let me draw this instead. There we go. So now we have angle, angle, side, angle, angle, side. So we have our information. Let's just put it into Delta Math. So we need to put in our given that AB is parallel to CD. And that's given to us. From that given, we drew the conclusion that we had the congruent alternate interior angles. So let me put that in. That was ABE that we had. And CD. And our reason is that alternate interior angles are congruent when lines are parallel. We have another given that AB and CD were congruent to each other that was marked in the diagram for us. So AB is congruent to DC, and that was given. And then we mentioned the vertical angles. So let me put that in. They're congruent to each other. That's BEA. And that's this one right here. And this one, that's CED. And our reason is going to be because we have vertical angles that are congruent. And that should work. We did it. One more to go, and then we're all done. And then this really long video can be over. So let's take a look at the next one together. So given D is the midpoint of AC. So I already know D is the midpoint of AC. So let me find D. It's the midpoint of AC. So I know it's turning AC into two equal or congruent parts. If you take a look at Delta Math, they want us to prove the triangle's congruent by AAS. That's what they tell us. So we already have it. We now, based on our givens, we already have angle, angle, side, angle, angle, side. So that one was a little bit simple. I mean, all we had to do. Let's go to Delta Math and type this in. So the only given that we drew a conclusion from was knowing that D is the midpoint of AC, and that was given to us. From that given, we drew the conclusion that AD and CD were congruent to each other. And that's because we have a midpoint that divides a segment into two congruent segments. Then we have our other givens. We have angle A is congruent to angle C. I see that in the diagram. So that's angle A congruent to angle C, and that is given. There we go. And then we had our other pair of congruent angles that was given to us, ABD, that's right over here. And CBD, that's right over here. And let me write down that that is given as well. And that should be enough to show that the triangles are congruent by AAS. And look at that, we are all done. If there's any other questions, you can make sure to email me. You can go to tutoring. There's tutoring in the morning and there's tutoring after school. Please see the tutoring schedule for more information on that.